Hello. Next technique is index set splitting. So while compiling, whenever we try to vectorize given loop, sometimes situation arises where it is not possible to vectorize given loop by any of the method which we have seen up till now. So if complete vectorization of loop is not possible, then next step is try for partial vectorization. So whenever loop is given and we have to vectorize it, first we'll try to vectorize the loop completely. For complete vectorization, first we'll try, and if it is not possible, then we'll try for partial vectorization. So sometimes it is possible that one part of the loop can be vectorized while other part has to be executed in sequence. So such type of technique where we try to vectorize partial loop are known as index set splitting. So it divides the loop into different iteration range to achieve the partial parallelization. So it is applied when all iterations are not involved in dependence. Okay, so there are some situation where complete vectorization is not possible, and whenever we draw a dependence diagram, then it is observed that all iterations are not involved in dependence. So if all iterations are not involved in dependence, then those iteration can be vectorized, while the iteration which are involved in dependence are to be executed in sequence. So this index set splitting is having three method inside that, uh, which are threshold analysis, loop peeling, and section based splitting. So we are going to see these three method one by one. So first is threshold analysis. So what is threshold? If you remember, in second chapter we discussed the threshold as the distance between source and sink. Okay, so it is the value uh, which is a distance between source and sink in the leftmost non-equal to part of the distance vector. So if you have this value is equal to 5, what does it mean? That the distance between source and sink is 5. So if source is first iteration, then sink would be in sixth iteration. So if source is in first iteration, sink is in fifth iteration, it means that second, third, fourth, fifth, this intermediate iteration are not having any role. Okay, so this can be vectorized. For better understanding, take this example, first example, which is a loop. Do I is equal to 1 to 20. Inside that you have a single statement, a of I plus 20 is equal to a of I plus b and do. So in this loop you have only one statement, and if you see directly that statement only, don't look at the definition of uh, the do statement, minimum and maximum value of I. Irrespective of that, if you see only the statement inside the loop, then you will find that it has a dependence, because on the left hand side you have a of I plus 20 and on right hand side you have a of I. So in first iteration a of 21 would be defined, and in 21st iteration a of 21 would be used in right hand side. Okay, so dependence is there. Now what is the distance? Okay, what is the distance between source and sink? Here the distance between source and sink is 20. Okay, so the value which is defined in first iteration would be used in 21st iteration. The value which is defined in second iteration would be used in 22nd iteration. The value which is defined in third iteration would be used in 23rd iteration. So distance is here 20. Okay, so in other words, you can say that threshold is 20. Now, if you look at the maximum value of I, then the maximum value of I here is 20. Okay, so if you look at the statement, then sync is at 21st iteration, but this loop is having only 20 iteration. So it means that sync will never be executed. So if you see this loop in totality, okay, not only the statement inside the loop, then you will find that there is no dependence in this loop. This loop is not having any dependence. All statements are independent and this can be vectorized. Okay, because distance between source and sink is 20 and number of iteration in this loop is 20 only. Okay, have you understood this? So this loop can be vectorized into a of 21 to 40 is equal to a of 1 to 20 plus b. Okay, so this is because of threshold analysis. Now take another example. Next example which is given in the box. Do I is equal to 1 to 100 and inside that you have same statement a of I plus 20 is equal to a of I plus b. So the statement is same. So here again the distance between source and sink is 20. That is threshold is 20. Now we have seen just in previous example that if we have only 20 iteration then there is no dependence. Okay, now we have 100 iteration. So to avoid dependence here, what we can do is we can divide this 100 iteration into chunk of 20 iteration each, and this method is known as strip mining. Okay, so dividing number of iteration into smaller group. So here we can have 5 different loop and each loop will execute 20 times. Okay, so this program can be converted into the given in the next block, that is do I is equal to 1 to 100 with step of 20 outer loop. Now inside you have another loop, do small I is equal to capital I to 1 I plus 19. So inner loop will execute how many times? 20 times. So if you see the inner loop and the previous program, that is exactly same. Okay, it is having 20 iteration and inside that you have a of small I plus 20 is equal to a of small I plus b. So if you see only inner loop, then there is no dependence. Source and sink will not be there in this loop. Okay, so inner loop can be vectorized. Okay, so in this example, inner loop can be vectorized, outer loop has to be executed in sequence. So this is because of threshold analysis. Now take another example for threshold analysis, which is crossing thresholds. So you see this example for crossing threshold. Do I is equal to 1 to 100. Inside that you have statement a of 100 minus I is equal to a of I plus b, and do. So see carefully what kind of dependency is here. In first iteration, a of 99 is calculated by using a of 1. In second iteration, a of 98 is calculated by using a of 2. In third iteration, a of 97 is calculated by using a of 3. So there is no dependence in initial few iteration. Okay, after that in 50th iteration, a of 50 is calculated by a of 50. Now what happens in 50? So what will happen in 51st iteration? A of 49 is calculated by using A of 51. Okay. In 52nd iteration, A of 48 is calculated by using A of 52. So if we see initial 50 iteration, there is no dependence among each other. Okay, so all initial 50 statements are having dependence on next 50 iteration. Okay, so first iteration is having dependence on 99th iteration. So in first iteration A of 99 is calculated. Okay, and A of 99 would be used on right hand side in 99th iteration. Okay, second iteration is calculating A of 98, and A of 98 would be used in 98th iteration. So first 50th iteration is not having any dependence. First 50th iterations are having dependence on next 50th iteration. Okay, so here threshold is 50. So we can convert this program into another program by applying strip mining, where we will divide this 100 iteration into two parts. So in first part, first 50 instruction would be executed, which is not having any dependence on each other, so that can be vectorized also. And in next part, next 50 iteration would be executed. This program would be converted into a nested loop. So outer loop will go from 1 to 100 on I with step of 50, and second will having a variable small I. It is going from capital I to capital I plus 49. So first value of I is 1 in outer loop, and second value would be 50. 51, sorry, second value would be 51, and in inner loop the first value of small I is 1, so inner loop will go from 1 to 50. Okay, so this inner loop will execute first 50 statement, okay, when value of capital I is equal to 1, and inner loop will execute next 50 statement when value of I is 51. So inside this inner loop you have statement, same statement, A of 101 minus small I is equal to A of I plus B. So here you can clearly see that inner loop is not having any dependence, because it is executing 50 statement at a time. Okay, first 50 statement in first execution and next 50 statement in next execution, which is not having any dependence on each other. So inner loop can be vectorized. So vectorized program is given right below that strip mine program, and here inner loop is vectorized, outer loop is as it is. So outer loop cannot be vectorized, that is to be executed in sequence, that is first 50 statement would be executed, and after completion of execution of all 50 statement, then only next 50 statement can be started. So this is all about threshold analysis.